All right, guys, today we're going to go backwards a little bit. We're going to figure out how big our sample size needs to be so that we can be, 95% confident or 90% confident in our interval. Like, how big a sample do we have to have before we can actually say that? What we did the last few days is, given a sample size, using that to find an interval where we're 95% confident. Now we're going to go backwards and we're going to say, okay, to be 95% confident, how big of a sample size do we need? So the sentence there at the bottom, if we plan to collect sample data in order to estimate some population proportion or a confidence interval, how do we know how many sample units must be obtained? So that's what we're going to do today, is figure out how many sample units we must obtain to be as sure as we need to be. All right, quick notation review, because it's been a couple days here. If you just see P, it means population proportion. P hat, remember, is our sample proportion. N is our sample size. Big E, capital E, is our desired margin of error. And we call this Z-crit. I forgot to put alpha over here, but I didn't have alpha on my keyboard, so I used a little a. Critical value separating error to the right of, it should say alpha over 2 right there. So just a quick review. I think you know all that anyway, but just make sure you know what the letters mean. Can't say those enough. All right, the sample must be a simple random sample. That's so important. We kind of breeze by that a lot, but every sample we take has to be a simple random sample. If it's not a simple random sample, everything's messed up to begin with, so that all this stuff doesn't really matter. Okay, 2 formulas that you got to have. First of all, let me tell you this where these formulas came from. They're the same formulas that we used the other day when we were looking for our error, except now we solved it for n. And I can show you that in class if you're really dying to see where it comes from. But basically, you just rearrange those formulas to get this. You know how to square root. So that's why you see the squares, because we had to get rid of the square root. Okay, if you know P, I forgot the P hat. If you know P hat, then we're going to use this one, where we're going to do the Z crit and square it times P hat, Q hat over our margin of error squared. Now, sometimes you won't even have a P hat. You may not know a P hat. And if you don't, what we're going to do is the same formula, except we're going to replace our P hat times Q hat with just a 0.25. And that's kind of a common statistical way to make up for the fact that we don't know those two. All right. If the computed sample is not a whole number, like if we get a sample size, or we're trying to find a sample size, and we get a decimal, we're going to round it up to the next larger whole number. We're always rounding up. I don't care if you get like 12.1, you need a sample size of 12.1, we're rounding that to 13. All right, you need the next whole number up. Better too many than too little, and that's kind of why they do that. You may think this is funny, but the formulas are remarkable because they show that sample size doesn't depend on the size of the population. It doesn't matter how big your population is. Sample size doesn't matter, and here's why. The sample size depends on how confident we want to be, how big of error we're going to have, and what our P hat is if we know that. So those are the things that are important. Confidence level, how confident we're going to be, what our error is going to be, what P hat is, not how big the population is, which is kind of weird when you think about it. All right, let's try one here. It says Gap, sorry about that, Gap, Banana Republic, J.Crew, Yahoo, and AOL are just a few of the many companies interested in knowing the percentage of adults who buy clothing online. Sorry again. How many adults must be surveyed? In other words, how big of a sample must we have in order to be 95% confident that the sample percentage is an error by no more than 3 percentage points? So 95% confident, no more than 3 percentage points. So part A, we're going to use our first formula we had, because it says this. Using the recent result from the Census Bureau, 66% of adults buy their clothing online. So there's our P hat. So we know P hat. So I'm going to use this one. I'm going to use that first one. N equals our Z crit. And Z crit, because it's 95%, is 1.96. I just remember that. We've done that so much. Squared times our P hat, which is 0.66. Times our Q hat, which you get by doing 1 minus P hat, 0.34, all over our margin of error squared. Now, our margin of error is 3 percentage points, which is really 0.03. Don't use 3. Make sure you put 0.03 down there and square it. That's a lot of stuff to punch in your calculator. When I'm punching mine in, I punched in before I made the video, and I get this right here. I got 957.839. Now, obviously, you can't survey exactly that many people. Remember, we always round up. So we're going to survey 958 people. Right, that's part A. Now part B, look what it says. Part B says, assume that we have no prior information suggesting a possible value of the proportion. So I don't know p hat, basically what this is saying. I have no idea what p hat is. So let me move this up a little bit. So in that case, I'm going to use the other formula. Still 95%, so I'm still using the 1.96, squaring it. But instead of my p hat and q hat out here, I'm just going to put 0.25. So I'm going 0.25. And I still got the same 3 percentage points, so I'm going 0.03 squared. Punching all that in, when I do that, I get this. I got 1,067.11. But remember, we always round up, so I got the 1,068 in that one. So to interpret what that means, it means this: to be 95% confident that our sample percentage is within 3 percentage points of the true percentage for all adults, we should obtain a simple random sample size of 958 if we know p, and 1,068 if we do not know p hat. All right, and that's all there is to it. So those two formulas are what you're going to be using majority of the time tomorrow. Okay, quick word of caution, and we're done. Try to avoid these two common errors, and people do this all the time, so please try not to do this. First of all, don't mistake, if they're going to tell you what the margin of error is, like 3 percentage points or whatever. When they do that, make sure that you use 0.03. Don't use just 3. I see people do that all the time. Number 2, be sure to substitute your z-crit. Sometimes people will see 95%, and that's what we just did, and we use 1.96. Well, sometimes people just put like 0.95 or 0.05. Make sure your z-crit, I think we've done that enough by now that you have to substitute your z-crit, but make sure you substitute your z-crit in there as 1.96, not the 0.05 or whatever. All right, all there is to it. Pretty short and sweet today, I hope, and not very difficult. We'll work on it tomorrow like we always do. I'll see you then.